No, Mr. Savini won't like that. So remember how we were multiplying to get rid of the fraction? Remember that? Remember that? How do we decide what to multiply by?
Whatever the common denominator is.
Whatever the common denominator is. Well, today is going to be just like that. We're going to multiply by whatever the common denominator would be, except now we're going to have some letters. Woohoo! Now we're going to have letters, but that's okay. What's my common denominator going to be? What's my common denominator be? Well, for the number part, I've got a 3 and a 3 and a 1. What's the common denominator with a 3 and a 1?
3.
3. And I've got an x and an x and no x's. How many will I need in my common denominator?
1x.
Just one, right? So your common denominator now is going to be 3x over 1. So we are going to multiply both sides by 3x over 1. Just like we did the other day, except we multiplied just by a number. That's okay. What do you get here? Right, 9x over minus 3x over 3x equals 6x over 3. Then we're going to go back and reduce. Look right here. Look what happens. Cancels and you just get 9. What is 3x over 3x? Yeah, anything over itself is just 1 equals right? Oh, look how easy that is. 9 take away 1 is 8. Divide by 2, divide by 2. So what do you get? X equals 4. And remember, we're not allowed to have any answers that would make your denominator a 0, right? Remember that? Well, if I put the 4, x is 4. If I put a 4 here, that's not going to be 0. If I put a 4 here, 3 times 4 is 12. That won't be 0. So I think we're good. I think we're good. X equals 4. Does that make sense? I think the hardest part is just going to be deciding what your common denominator is. Once you get the common denominator, you have to multiply both sides, every single term, by the common denominator. Easy, right? Questions so far? Questions so far? 3, x squared minus 7x plus 10. I should have left more room there. Plus 2 equals x minus 4 over x minus 5. I'll put a 1 under here. Oh boy. Remember, we got to figure out what the common denominator is. Oh my. From this to that. Remember over here, I need to have one of those. I need to have one of those. It's just now that one of those things I need is now going to be a whole x minus 5. Remember the good old days when I could come right up to you and get in your face? Remember that? Remember the good old days? No, I have to stay back. What do you have to do here before you can figure out the common denominator?
Factor it.
Right, you've got to factor it. Oh, and as long as I'm putting parentheses, I'll put parentheses around that too. I think this is what you meant. We have to factor. What does that factor into?
X minus 2, X minus 5.
Oh my, you're quick. X and X, 10, 2 and 5. What did you say for the signs?
Minus.
Minus, minus. So instead of this, we have that for our denominator. Now it might be a little easier to figure out your common denominator. What is the common denominator going to have? One of those and one of those, right? And remember, what do we do with the common denominator? We multiply both sides by it. So it's got to have an x minus 2, and it's got to have an x minus 5. My common denominator has to have an x minus 2, and it has to have x minus 5 over 1 over 1. What are we going to do with that? We're going to multiply both sides by it, right? Just like yesterday, or the day before, or whenever that was. When you multiply this, I don't want you to really multiply it right away. We're going to do 3 times this stuff. So 3 times x minus 2, x minus 5, over 1 times this stuff. X minus 2, x minus 5. Plus, oh boy, now we're going to take this stuff and multiply it by 2. Now we're going to take x minus 2 and x minus 5 and multiply it by the 2. Over 1 times 1. Then on the other side, this times, so x take away 4, x take away 2, x take away 5, over x minus 5. Are we good so far? I didn't really actually multiply anything yet, I just wrote it out. And why didn't we multiply it? Because now we're going to go back through and cancel some stuff, right? What will we cancel? Oh, look at this. This and an x minus 5. Woohoo! I just have 3 there. Unfortunately, this one, nothing cancels. X minus 2, x minus 5 equals the last one. At least the x minus 5's cancel. So I have x minus 4, x minus 2. Oh gosh, now what? Remember, when we're all done, we want to know what is x equal to. I know that's how I feel, Kobe. What do we have to do next? Are you breathing even? Right, good, yes, you're going to have to multiply it out. You're going to have to FOIL a little bit, right? See all this stuff? You actually have to multiply that out. See all this stuff? We got to FOIL that all out. All right, here I go. I'm going to leave that 3 alone. And 2 times whatever I get when I FOIL this? Should we FOIL it? X squared minus 5x. And then move over. Now negative 2x plus 10 equals, and we have to FOIL this as well. Oh my gosh. X squared minus 2x. X squared minus 2x. Move over. Minus 4x plus 8. I hope you're checking. Make sure I don't make any mistakes. Did I make a mistake, Marshall? Oh, good. Now combine like terms. Inside here I have some like terms. 3 plus 2x squared, is that minus 7x? Here's some more like terms. Before we get it all together, we got to multiply this stuff by 2, don't we? Don't we? Oh my. 2x squared minus 14x plus 20. Nothing over here yet. On the left side, I think we have a couple like terms to combine. This. So 2x squared minus 14x plus 23. Oh my Lord. Now what?
Move everything.
Get it all over to the other side, equal it to 0. So I'm going to subtract x squared, add 6x, and subtract 8. I'm going to subtract x squared, add 6x, and minus 8. Whew. I think I'm going to deserve a little sip of dew after finishing this whole problem. Two x squared, take away an x squared. I think that's 1x squared, right? Negative 14 and positive 6. Negative 8, I think. 23 take away 8. Oops, plus 15. We're almost there. I'll do this part, x and x. What multiplies to 15 and adds to 8?
5 and 3.
5 and 3. It's a positive, so either plus, plus, or minus, minus. Oh my gosh. So now I'm multiplying these two things together and I get an answer of 0. That means either x minus 5 equals 0 or x minus 3 equals 0. Add 5, and you get x equals 5. Add 3, x equals 3. Beverly, is that the answer the book got? What is? Both of those? Part of it, yeah. Part of it, what?
At the bottom, there's like a check mark.
There's like a check part. Do they both check out? They don't, right. Here's why. Remember, you're not allowed to have a denominator that's equal to 0. So if you plug either of these in and they make a denominator equivalent to 0, you need to throw it out. If I put x equals 3, if I put 3 take away 5, that's okay. It's negative 2. It's not 0. If I put 3 take away 2, it's 1. If I do 3 take away 5, it's negative 2. So if I plug 3 in, none of these denominators will equal 0. So that means this one checks out. However, if I plug in x equals 5, right off the bat, right here, what's 5 take away 5? What's 5 take away 5?
0.
That's not allowed. So if 5 take away 5 and the denominator is 0 and that's not allowed, can this be an answer then? No. Throw it out, throw it out. You have to throw it out. So you end up with only one answer. So when you're all done, you have to just check the denominators. You don't care about the numerators. The numerator can equal 0, but the denominator can't. So after you do all that work, then you got to plug it back in here into the thing you factored and make sure it doesn't equal 0. Does that make sense? If it does equal 0, you have to throw it out. And you want to know what will happen occasionally? Talk about stink. You do all this work, you get to the very end, you get 2 answers, you plug one in, it makes the denominator equal to 0. Throw it out. Then you plug the other one in, it makes the denominator equal to 0. What do you have to do with it? Throw it out. And then guess what you have left for an answer? Nothing. It's no solution then. After you did all that work, wouldn't that stink? You practically want to cry. Make sense? Oh, look at all that math you need to know how to do. The factoring, the canceling, the foiling, the solving by factoring, where you got to get it equal to 0 and then factor it again. Whew. That's why I don't give a cumulative exam, because in order to be able to do this problem, it really is cumulative, right? You have to know how to do a lot of stuff to be able to solve this. That's why math is not a good thing to say, well, I sort of bombed first semester, but now I'm going to really kick it into gear. Now I'm going to really get going and work hard. Well, it's kind of hard because now you needed to know how to do this stuff we already learned. So, make sense? And really, the only new thing is multiplying by this odd-looking common denominator. We already did common denominators, remember? So you should be able to figure out what it is, but now we're going to multiply by it. And you get weird-looking things, but then cancel, and it won't be so bad. Does that make sense? Do you have questions? Are there any questions? Does anyone have a question? Would that be page 249? Yes, I think that would be page 249. That would be page 240. One to 19. I don't think I have COVID. It just feels like I swallowed a bunch of others. That's it. You can check your answers in the back. Now, why is there an empty seat back there? Who is sitting there on the lawn? Oh, right. Oh. Oh, boy.